today we're moving on to a little bit, I guess, harder stuff. I taught you guys about monomials and like powers to powers, but now we're going to move on to a little bit more difficult called polynomials. So monomials being one, poly means many. So there's different kinds of polynomials. First one that you'll run into is a binomial and multiplying those together. So there's different methods of multiplying things together. I'll teach you two different methods and you can choose which way you like. So our first method is FOIL. I say it really weird instead of an accent. So FOIL is first, outside, inside, and last. So what does this mean? This means if we're given this binomial times by a binomial, 2y minus 5 times 3y plus 1, this is how we're going to multiply it. We start by multiplying the first terms, so these two and these two, and we get 6, it's not a 6, guys, 6y squared, and then we do the outside, so this one and this one, plus 3y, and then the inside, minus 15y, and then the last one's minus 5y, or not minus 5y, just minus 5, hello. Again, making mistakes, I always do. And then just combine your like terms, which are right here. We get 6y squared minus 12y minus 5. And that is multiplying binomial together. Two binomials together. So that's the FOIL method. I do like that method, but there's another method I like even better. It helps me keep track better when I'm using it. I didn't use it on any of these, I used FOIL. So let's do another one using FOIL. My old roommate used to make fun of me when I would say FOIL, or oil, because it sounded like I was saying whale. I'm from the South, with a weird accent sometimes. So 6m minus 5n times m plus 2n. So if we're going to use FOIL, I love my accent, I miss it. So if we're going to use FOIL, first, so that's 6m squared outside, that's 12mn inside, negative 5mn, and last, negative 10n squared. Then combine your like terms, and I like to always put my variables and exponents. I put them in alphabetical and then, so it's alphabetical order, and then I do the exponents in descending order. So in this case, how I would write something like this is I would do 6m squared minus 10n squared, because that comes next in alphabet and in power. And then 12 minus 5 mn is plus 7mn. I went slanted. So this is the FOIL method. And FOIL is fine. It really is. But still losing my voice. So let's look. There are some special cases. So let's look at these special cases. So if I'm given one that's like this, 5m plus 4, 5m minus 4, we can do the FOIL method, but there's certain, this is a special case we have here. It's called it's a difference of binomials. Okay, binomial difference right here. Because it's pretty much the exact same thing, right? So you're multiplying by the sum and the difference of the exact same thing. So I'll show you what happens with this one, and then we'll do another one the fast way. So what happens with this guy using FOIL, we get 25m squared. First outside is minus 20m, inside plus 20m, and last is minus 16. Well, what happens is these go away, and we're left with 25m squared minus 16. So all that happens is we squared this and squared this, and it made it negative. That's all that happened in there, is it got rid of the middle terms, because it's a difference times a addition. I don't know why I can't think right now. It's probably because it's super early in the morning for me. My son woke up and started playing Xbox. So, if we're going to look at this guy then, 4r minus 9s and 4r plus 9s, I don't even have to do FOIL because I see that it's the same one, just with a negative and a positive. So I already know that I'm just going to square this term, 16r squared, and square this term, u1s squared. And that's your solution for that. So, that's kind of nice. When we're multiplying by a sum and a difference, that's what happens to it. Sum and a difference with the exact same numbers has to be that. That's a special case. So another special case is a binomial squared. So this is something that we have like this. 4a plus 7 squared. So when we see something like this, pretty much what we're doing, so I'm going to take this guy out, and I'm just going to add another 4a plus 7. Because that's what we're doing, is we're multiplying it by itself. 4a plus 7 squared is multiplied by another 4a plus 7. That's what this is. So first, 16a squared, and then outside, 28a. Inside is also 28a. And then last is 49. Because 7 times 7 is 49. And then add these two. 16a squared plus 56a plus 49. So that's another special case. And you can do the same thing with, guys, so early in the morning. The subtraction one. So let's do that. So it hasn't even hit 8 o'clock. And I'm just, woo! That's bit late. Waiting for someone to call me. They never did. So I'm doing it really late. So if I see 10m minus 3n squared, take this guy out and just write another 10m minus 3n. And then multiply through. So I get 100 n squared minus, hang on, because I did this math wrong on here, guys. That's funny. Because this is first outside, minus 30 mn, inside minus 30 mn, and then it wrong on mine. And for some reason I did not add these two together. So I will do that now. N squared minus 60. Oh, I did it the other way. I like to do it in descending order. So I did the n squared. I don't know why I made that a cube. N squared and then minus the 60. And I am going slanty today, and I apologize for the slantiness, but that's what's happening because I'm exhausted, and so I will be slanting today. Look at that slant. Woo! Okay, so now that we know binomials, so I said we were going to be doing polynomials. Polynomials means many, and it does. So here's another way that I like to do polynomials. So if I'm given x cubed minus 5x squared plus 2x, and I'm multiplying that by 2x squared plus 3x minus 1. Well, how are you going to use FOIL in this guy? This has 3 in each one. That's kind of hard to do. So, this is what I do for this instead. I'm going to draw a box. A nice, useful box to put things in. And I need 3 columns and 3 rows. Okay, so now that I have my cute little box, I'm going to put this equation right here. So I have x cubed minus 5x squared plus 2x. I'm going to put this equation right here. 2x squared, 3x minus 1. Okay, now we're going to multiply this, and it goes here. So x cubed times 2x squared. This is why we needed to know exponents, and I taught you guys exponents already. When we're multiplying this, you're just adding the exponents. So then it's 2x to the 5th. Now let's move on to this guy. 3x times x cubed is 3x to the 4th. And x cubed times negative 1 is negative x cubed. So that's our first row. Now let's move on to the second row. Negative 5 times negative 2, or not negative 2, negative 5 times 2 is negative 10. And then x squared times x squared, x to the 4th. Negative 5 times 3 is negative 15. X squared times x, x to the 3rd. And negative 5x squared times negative 1 is a 5x squared. Next row. 2 times 2 is 4. Oh my gosh, guys. X times x squared is x to the 3rd. 2 times 3 is 6. X times x is x squared. And 2 times negative 1 is negative 2 and x. Now, I have all of my numbers and my x's that I'm going to combine my like terms as I go, as I write them, because this is a like term, these 3 are like terms, that's a like term. So I start here. I see that my 2x to the 5th is not a like term. So it's the beginning of my equation. Well, negative 10x to the 4th plus 3x to the 4th is a negative 7x to the 4th. And then we do 4x to the 3rd minus 15x to the 3rd, which should get me to negative 11x to the 3rd. Then minus another x to the 3rd, that's negative 12x to the 3rd. And then 6 plus 5 is 11x squared. And then there's nothing to combine with this guy. We get 2x. So this combines with this, this combines with this, and this combines with this. And that is how we have made that polynomial together. We have multiply it together. It's a lot of process, but I find the boxes easier to control. I like them better, honestly. Well, let's do another one. Hopefully you guys are grasping this. I know it's a lot of information to throw at you because we're going to be doing this, and then I'm going to move on to factoring as well. Because factoring is important, guys. This is going to be a fun lesson. I like this lesson. All right. So if we're given x squared minus 4x plus 2, we're multiplying it by 3x squared plus x minus 5. Let's draw our box. Kayla, did you go upstairs? No. Huh. All right. Never mind. It sounds like somebody's upstairs. Hello. It just sounds like someone's upstairs. I didn't think the cats made that much noise. Okay, so I made my box. So x squared goes here, negative 4x, and 2. Put my 3x squared over here, and my x, and my negative 5. So, now let's multiply things. 3 times 1 is 3. X squared times x squared is x to the 4th. 3 times a negative 4 is a negative 12. X squared times x is x cubed. 3 times 2 is 6, and there's no x, so we just leave the x squared. X times x squared is x cubed. X times a negative 4x is negative 4x squared. X times 2 is 2x. Negative 5 times x squared is negative x squared. Negative 5 times negative 4 is 20x, because that's positive, is negative and negative. Negative 5 times 2, negative 10. So, let's combine some like terms. Ugh. I know that I'm going to be left with 3x to the 4th, so nothing combined with that, but these two can combine. So negative 12x cubed plus 1, negative 11x cubed. Combine this guy and combine this guy. I'm going to do the 6x minus 5, which gets me to x squared. And then minus 4x should get me to negative 3x squared. Right here, get positive 22x, and then minus 10. And that is now multiplied together. He's talking to himself upstairs. He's seriously talking to himself upstairs. That is multiplying polynomials. So now we see the concept of multiplying polynomials. Let's try divide. Everybody's favorite.
She wanted the snack.
I don't want the cookies. You can have the cookies. Is anybody upstairs?
No.
Oh.
It's just me and giving these pizzas.
You got pizzas?
I got the pizza then.
Okay. We'll go get drinks later.
Okay.
Okay. Alright, we're going to divide
I'm gonna
polynomials.
stay here.
Okay, then you can stay here and I'll go get drinks. This is my life, guys. We're going to divide polynomials. So, if I'm given this polynomial, this looks big and it's going to scare you guys, I know. There's loss of mind in there. Over negative 7b. So if we see something like this, there's an actual little secret we can do. I will show it to you. So this looks scary, right? You guys are like, oh crap, there are way too many numbers here. It's all over one. I don't know what to do. Well, I'm going to take my negative 7b to the 5th and move it under every single one, because that's what it's saying. You're dividing every single term by a negative 7b to the fifth, and then we're just going to end up combining it at the end. So negative 28 divided by a negative 7 is a 4. And we learned with exponents, we're just subtracting. So 13 minus 5 is an 8. And then 49 divided by negative 7 is a negative 7. 8 minus 5 is a 3. Negative 63 divided by a negative 7 is a 1. Or no, is a 9. See, my brain again. And then 5 minus 5 is 0, so the b goes away there. And that is divided. So division really isn't as bad as you guys think. Honestly, it's really not. Just, you know that every single term is getting divided by that, so I just add it under every term, and then I know it keeps track of things I need. So, apparently there's a dog in Minecraft. So, 18x to the 4th minus 12x to the 3rd plus 6x squared, and it's all divided by 3x, negative 3x. So that's all off to the side, and it's all being divided by negative 3x. So let's erase this guy here and move it under each one. So 18 divided by negative 3, negative 6, and then 4 minus 1 is 3. Negative 12 divided by a negative 3 is a 4, positive. 3 minus 1, 2. 6 divided by a negative 3, negative 2. And then 2 minus 1, 1. That is dividing polynomials. But what if we are given, I have to remember how to do these, hang on. It's been so long since I've done these ones. Guys, I don't remember this. Whew. Trying to think. I will figure that one out. It's been a while since I've done the long division. Polynomial dividing, so I'm looking over my work and I can't even see what I did. It's been so long. So I will figure this out and make a different lesson for that, because it's important, but for some reason my brain cannot process how to do long division with polynomials right now. Why? I don't know. Okay, so let's move on to factoring. I like factoring. I taught you a little bit about it with the factor trees, but now we're going to get a little more intense with it, I guess. So, we always have to find our GCF. GCF is our greatest common factor. So if we're looking at something like this, 18a minus 9b. Daisy, can you not be up there, please? She's about to go stand on the projector again. So if we're looking at this guy, we need to find what our greatest common factor is. Well, what do you think our greatest common factor is between an 18 and a 9? I see a 9. There's nothing I can pull out of an A and a B, so those are going to stay in my parentheses. But 18 divided by 9 is 2A. 9 divided by 9 is 1 minus B. Because if I were to take this back in and multiply it through and distribute, I'd get the exact same thing. We're just pulling out, and then if you want to like distribute it back in, that's great. You know, you're just making it like expanding it. I guess you need to do that. So early in the morning. So let's look at it this way then. So if we're given this 9a cubed minus 36ab plus 27a squared. Let's find our greatest common factor. So look at the numbers first. I think Daisy just got stuck under something in the closet. So look at our numbers first. Well, I see our greatest common factor in numbers is 9. Is there a greatest common factor in the letters? Well, I see I have an a cubed, an ab, and an a squared. Well, each of these has an a in it. So I know I can take at least one a out. So now that I do that, 9a cubed divided by 9a is a squared. Negative 36ab divided by 9a is 4b. 27a squared divided by 9a is 3a. And that is factored. I'm pulling stuff out. Pulling stuff out to put it back in. Pretty much it. So, we're given something like this. 2a times b plus 3c plus 5 times b plus 3c. This might look a little confusing, but looking at this is one term, this is the other term. What is our greatest common factor? Our greatest common factor is this guy. So we're pulling out of each of these a, b, plus 3c. And when I do that, I'm then left with this 2a plus 5. And if I were to FOIL that, I'd get this again. Factoring. Opposite of FOIL. You know, hey. Right? Right. It just looks confusing sometimes. And you're like, oh my gosh. It's not hard. So, let's do something called factoring by grouping. Oh, my nose is killing me tonight. I'm so tired. I'm very, very tired. So if we're given this 14m plus an plus 7a plus 2mn. So if we're looking at this, nothing that is next to each other can factor, right? And so you're like, oh crap, what do I do? Oh my word. Kitten! Oh, hang on. She's on the projector. Hey! Get down. Get down. Come here. Come here. Thank you. Oh my Lord in heaven. Okay. Sorry. So, there's nothing that can factor right now, really, that's put together. But this states in our addition properties, you can move things around to make them match the way you want, because anything added to each other will still add to each other. Kitten! Kale, what are you doing? Oh, kick this cat's butt. We do not climb on the projector. What are you doing?
I'm just squishing the potato.
Why? It's fine. She's not there anymore. Anyway. I'm going to do is I'm going to move some things. So I'm just going to do 14m, and I'm going to put this next to it. And then I'm going to put the plus an plus 7a together. So I've grouped them a little bit different, but it's going to make my factoring easier. Because now I can factor this guy and then factor this guy. That's our whole point. We need to factor certain things. So, what can I take out of the 14m and the 2mn? Well, I know that I can take a 7n, no, a 2m, sorry, 2m. So I'm taking a 2m out, and I'm left with 7 plus n. Yeah, 7 plus n. So then I look at this guy. What can I take out? Well, I can take out an a plus a, and then I should get the same thing where I'm doing 7 plus n, because I can rearrange it. So now looking at this, where are our factors that line up and are perfect? Well, this one and this one. So one of mine is 7 plus n, and the other one is 2m plus a. That's factor by grouping. Just moving things so it makes a little more sense in your head. And then I factored it all the way. Ta-da! Loki, guys. They love that projector and it bugs the crap out of me. Get down. Hey. Get down. Get down. Thank you.
I need to sit them down.
They're fine.
Oh.
Thanks for walking in front of my video. Goober.
I don't know.
Are you still playing?
Yeah.
Okay.
I'm still playing. I'm still playing. Left 4 Dead.
Oh, you're switched to Left 4 Dead?
Yeah. I hate Minecraft.
He hates Minecraft now. Alright, so let's look at this one. 12ay plus 4by minus 15a. Why did I cross one out? I think I had to. Minus 5b. Okay, well, let's look at this guy. There are different ways we can group this, but I feel like I just want to keep it in the same way, because I don't feel like I need to change anything. Because I could group the 4 and the 4by and the 5b together, and then the 12ay and the 15a together. But I feel like this might be a little easier just to keep it. So let's factor this guy first. Out of this, I can take a y out, I know, because there's a y in common. But a 12 and a 4, I can take a 4 out. And I would be left with 3a plus b. Okay. Here, this is what I had to do that. Brain. I'm going to be taking out a negative 5. Take out the negative. Always take out a negative. So negative 5. And I'm going to be left with a 3a plus b. So now looking at this, where are our matches? Right here and right here. So 3a plus b, and we're left with 4y minus 5. Factored. Can you not? Get out. Let me clip your guys' nails. I'm losing my voice. So that's simple factoring. But what if we get into this one? Sorry, I'm running around in circles because I don't know where my paper. This is called factoring trinomials. So this means we have 3 terms. So if I'm given one that looks like this, x squared minus 10x plus 16. Well, yeah, okay. The way we do it, this is term A, term B, term C. What we have to do is we need to multiply A and C together, then it has to add up to get to B. So I like to make a little t-chart over here of all my factors of A and C multiplied together. So I know I have a 16 because 1 times 16 is 16. Well, what are the factors of 16? Well, the factors of 16 are 4 and 4, and 1 and 16, and 8 and 2. So we need to figure out which of these will add up to when multiplied together. So they have to be multiplied together to equal 16, but add up to a negative 10. So looking at this, 8 and 2 will do that, but they both have to be negative to do it. Because negative 8 times a negative 2 will equal a positive 16, but added together will equal a negative 10. So then all we have to do is this. And I have factored that trinomial. Right? Let's try another trinomial. So I have a squared minus 2a minus 15. So it looks like this guy, we need factors of a negative 15 that add up to a negative 2. So looking at this, I know that one of my factors is 1 and 15, always, and then 3 and 5. But one of these is going to have to be negative, because that's just how it's going to have to be, because it has to end up negative back here. But this also has to be a negative 2. So 3 times 5 is 15, but 3 times a negative 5 is negative 15, and then negative 5 plus 3 is a negative 2. So we have a plus 3, a minus 5. Multiply that back together and you would get this. So if we're given y squared plus 3y minus 18. So let's write down our factors of 18 over here. I have 1 and 18, I have 2 and 9, and I have 3 and 6. Okay, so looking through this, I need something that will multiply to get me a negative 18, but add up to get me a positive 3. So looking at that, what do you think we're going to have to do? Well, I know that 3 and 6 will be perfect for this one, but which one's going to have to be negative? Well, the 3 will, because to add up to a positive 3, the smaller number has to be negative. So y minus 3 and y plus 6. Because multiplying that through, you would get this again. Trinomials are really not that hard. I like them. So now looking at this guy, this looks a little more confusing, huh? Y to the 4th minus y squared minus 6. So don't let the exponents fool you. Just don't worry about them right now. What we're going to do is still do our a times c. So 1 times negative 6 gets us to negative 6. I know my factors are 1 and 6 and 2 and 3. Well, we need these to multiply together to be a negative number, but add up to be also a negative 1. So which one has to be negative? Well, the 3. to be just like a y and a y. So I have y plus 2 and y minus 3. But since we have this y to the 4th, it's actually going to be y squared. Because y to the 4th is in front instead. That's easy, right? I actually like factoring by trinomials. I keep telling you guys I like all this stuff, because I really do. Okay, so now let's move on to something a little bit more scary that could, oh crap, it's a trinomial, but it's got something else in front of it. What do I do? And people panic. So, what if we're given this? 3x squared plus 18x plus 24. And we need to factor this. Well, crap, right? No. Let's take the 3 out because that's the greatest common factor. We just learned that we can take the greatest common factor out, so let's do that. So we're going to take the 3 out. So 3x squared plus 6x plus 8. So now, we took 3 out, so I'm going to just put him off to the side here. Okay? So I'm going to ignore him for a minute, because I know he's part of my solution, so I'm just going to ignore him. But now I'm going to factor a trinomial. So my a times c is 8. I need factors that add up to 8, so I have, or add up to 6. So I have 1 and 8 and 2 and 4. Well, 2 and 4 will add up to 6. So then I have x plus 2 and x plus 4. But don't forget about this little dude we had over here. We just tack him on right there. Pretty cool, right? These are probably so sick of me saying that. But I'm sorry, I think it's cool. So now that we've seen that, let's move on to one that is a tad bit harder. So we're given this guy right here. 4x squared plus 6x minus 70. Well, this one's not going to be as nice, right? Well, it's not. It'd be kind of mean. I don't know what I did. I did something weird. Trying to see what I did on here. I'm trying to see how I did this, and I can't. So I know that I took a 2 out, because that's my greatest common factor, and I'm left with 2x squared plus 3x minus 35. Well, now that I did that, I have to multiply by the a and the c, and I get factors of negative 70. Yeah, this is what I did. I'm smart. So I get factors of negative 70, and I have to have them add up to 3. Well, what are my factors of 70? I have 1 and 70, 2 and 35, and negative 7, or not negative 7, 7 and 10. So they have to add up to a positive 3, but multiply to a negative 35, or negative 70, because, yeah. Because I'll show you guys what's happening. Because this times this is this. It's a whole process. I'll show you what's going on, I promise. So once I get there, I know that this has to be a negative. So because of this 2 here, what I actually have to do is I'm going to have x minus 7 over 2. This is where this 2 is now moving to. And then x plus, oh my lord, guys, plus 10 over 2. And then, I have a 2. And then what I did, what did I do? I don't know what I did. Oh. And then I just moved the 2, but I divided here. So actually I would have x plus 5. And then this 2 is just going to move, chill it on here. And we have 2x minus 7. and a 2. And that's factored. So that just added an extra like step to it, which is so much fun. Took me a little bit to remember what I did on here. Sometimes even the greatest minds forget everything. And I'm not a great mind. I'm not even like saying I am. I struggle still because my brain, I have a brain injury. And so sometimes I still struggle thinking about simple math. And to me, this is simple math. Okay, so what if we want to factor special cases? So I'm given this y squared plus 4y plus 4. So I can see already perfect square, perfect square, perfect square. My a in this one is 1, my b is 4, and my c is 4. So we know we need factors of 4 that add up to 4. That's 2 and 2. And so I would actually have y plus 2 times a y plus 2. But look, they're the same, right? So we can just write this as y plus 2 squared. Special case. Amazing. Cool. Alright, so there's two different things I want to teach you here. So this we have, so if I'm given something like this, and then something like this. So this is a difference of squares, and this is a sum of squares. So a sum of squares, we cannot factor. Because it is prime, and we can't factor it all. A difference of squares, so if you see a square minus a square, is actually going to factor nicely like this. A plus b, a minus b. Okay? So a sum of squares can't factor, difference of squares can. So let's look at this. If I'm given k squared minus 100, I know that this is a perfect square, and so is this guy. So to factor it, I know I'm going to have a k minus 10 and a k plus 10. Difference of squares, factored. But if I'm given y squared plus 9, that's a square and that's a square, but it's a sum of squares, so it cannot be factored. It is prime. So that's the basic concept of difference and sum. I like that concept. So let's look at one where it's not exactly in that formula yet, and so you're going to make it in that formula. So if we have 12x squared minus 3, we need to factor something out first. So I'm going to factor out a 3 first. 12x divided by 3 is 4x minus 1. Or 4x squared, sorry. 4x squared. So now, this is a perfect square, and it's 2x minus 1. And it's a difference of 2x plus 1 with a 3. So, make it a difference of squares. Cool. Again, I say cool. So much. Okay. Now, I've taught you the different ways to factor. Now, we're going to factor completely. So factoring completely means we just go down as far as we can until there's no end. And it just stops and we have a huge factoring like thing. And that's what I call it. So if I'm given this 64 e to the 5th minus 4e. Well, I'm going to take something out. I'm going to take a 4e out because I can. Because that's common. So 4e. 64e divided by 4e is 16e to the 4th minus 1. Well, right here, that is a difference of squares. So I have a 4e out here, and then I have a 4e squared minus 1, 4e squared plus 1. But keep looking, we're not done yet because this is also a difference of squares. So then I have a 4e, I'm going to put this guy first, so 4e squared plus 1. This is a difference of squares, so now it's 2e minus 1 and 2e plus 1. Now I can't go any further. This is factored completely from this. This is factoring completely. We're just taking it as far as we can until we can't go any further. That's factoring completely. And it's really not any more difficult than what we were just doing. It's just a lot more steps if you had to. Like this one, we just kind of had to keep going until we couldn't stop anymore. So, let's do another one really quick before we move on to the last point today. So let's do, trying to find one. Here's a good one here. 75 g squared minus 108 h squared. So looking at this guy, I know that I can take a 3 out. So I'm going to take a 3. And this is actually going to leave me with 25 g squared minus 36 h squared. That is a b. Okay, well looking at this, oh my lord, this is a difference of squares. And we know difference of squares, 5g minus 6h, and 5g plus 6h. Get them out of the bathroom and shut the door then. So now that is all factored. Make sure they're not in. Thanks for letting everybody know on the internet. That's my kid. So that's all the way factored. So now we're looking into solving quadratics using factoring. I'm trying to see how I remember to do this. It's my brain. Sometimes struggles still. So the standard form of a quadratic is ax squared plus bx plus c, which is what we were just doing, but we're doing the added bonus of equaling 0. So if I'm given 5x squared plus 7x minus 6, so we're just, and then r equals 0, has to have difference 0. So we're just factoring like we just were a minute ago, but this time we're actually going to solve each one of these. So 5 times negative 6 is negative 30. And we need factors that add up to a 7. And so 30, we've got, what, 5 and 6 and 10 and 3. But it has to be a negative 6 and a positive 7. So I know my 3 has to be the negative. So I know that I have an x plus 10 over 5, because the 5 will go on the bottom, and an x minus 3 over 5, because the 5 will go on the bottom. But now we just have to find the solutions, because these are equaling 0. This is what a quadratic is. We're actually finding the solutions to this. So now we're going to take each of these, set them equal to 0. So x plus 10 over 5, oh my gosh, 10 over 5 equals 0. X minus 3 over 5 equals 0. And now we just solve it. So we know that 10 divided by 5 is 2. And then just minus 2. So x equals 2. So one of our solutions is 2. And then the other one, just add 3/5. And the other solution is 3/5. Minus 2, sorry, negative 2. So our solutions are negative 2 and 3/5. So these two solutions will solve this equation. This is the goal of our quadratic right now, is we are trying to solve it. That's why we're setting it equal to 0. So what if we're given an equation that's not in this nice formula yet? So we're given this guy right here. We have x minus 5 plus x squared equals 10 plus 3x. And we know that we have to get it saying x squared plus x plus something equals 0. So we need to move stuff. That's our goal right now. I have to move things. So I'm going to minus my 3x and minus my 10. And then I'm going to rearrange it because I want it in descending order. So now I have x squared minus 2x minus 15 equals 0. So now that I have that, now I multiply my a and my c. I get negative 15. So I need factors of negative 15. So I have 1 and 15 and 3 and 5 that add up to a negative 2. So I know my 5 is going to have to be negative. So then I have x plus 3 and x minus 5. And now set each of these equal to 0 to get your solutions. So x plus 3 equals 0 and x minus 5 equals 0 minus 3, add 5. So our solutions are negative 3 and 5. Those two will solve this quadratic. That is the entire point of this section. So let's try this last guy right here. So if I'm given x squared minus 5x divided by 2 equals 7. You're probably wondering, like, oh my gosh, what am I going to do with this? Panicking, it's a fraction. Well, let's get rid of it. Multiply by 2 on both sides. So this goes away, and I get x squared minus 5x equals 14. But we have to get it into that nice quadratic form, so I need to move the 14. So I'm going to minus my 14 from both sides. So I get x squared minus 5x minus 14 equals 0. So now multiply my a and my c. So I get factors of a negative 14. And they have to add up to a negative 5. So I know I have 1 and 14 and 2 and 7. And then if they have to add up to a negative 5, I know my 7 has to be negative. Now I just put it into the parentheses as x minus 7 and x plus 2. And then we just set them equal to 0. And these are really easy to set equal to 0 because you can just look, well, this set equal to 0, I have to move that over. So I know one of my answers is 7. Moving this over, I know one of my answers is negative 2. So 7 and negative 2. So that's how we solve quadratics using the factoring. We haven't gotten to the actual quadratic formula yet. That'll be later on. Tomorrow, I feel like we're going to be doing rational expressions and equations. That'll be fun. Loki, please Please move out of the way. So we're moving on to a little bit harder math right now, which I find enjoyable, and I bet you guys are kind of so annoyed of me saying that. And I know my last video, for some reason, it did not flip the way I wanted it to, but when I went back and rewatched it, at least on my iPhone, and I've made it full screen, I could hold it straight and I watched the whole video without any issues. So I don't know what happened, but if that's easier, you can do that, but I liked the last video. So until tomorrow.